The first chapter of physics is kinematics. In kinematics, we will discuss about the motion of particles. Now, the kinematics is the part of mechanics where we describe the motion of objects, usually called particles, without considering the reason why the motion happened. The reason will be discussed under the section that is called laws of motion. Now the question arises what a particle is. As we know, when a body moves, it vibrates, it oscillates, it rotates. So the motion is very complex. So we reduce the complications by considering the object as a particle, and here we will focus only on translational motion. A particle means a point-like object need not be very small in usual sense. We treat big objects as particle. Now suppose, for example, watch this star A. This is star B. As we know, these two stars are very large. But as compared to the separation between these two stars, if you see the separation as compared to this separation L, the size of these two stars are very small, and we can treat these two stars as particle. Now, if we watch these two stars while sitting on Earth, so from here we see these two stars as a particle. But we know these two stars are not particle, but still we treat these as particle because when we are watching these stars, we are comparing the size of this star with the distance, that is L, which is very small. The size of this star is very small as compared to this L dash, so we treat this star as a particle. Now watch this car. Suppose this car is moving on a horizontal road like this. If this car move for a large distance, now suppose if the length of this car, let the length of this car is 3 meter. If this car travel 30 meter or 100 meter, in that case we can never treat this car as a particle. But if the distance traveled by this car is 50 km, suppose 50 km, travel distance 50 km or 100 km. So as compared to 50 km or 100 km, the length of this car is very small, so we can treat this car as a particle. For this distance, the car is treated as particle, whereas for 30, 40 or 100 meter, this car is not treated as particle. Now the next heading is the meaning of translational motion. Here in this chapter, we will focus only on translational motion. An observer call motion translational if each part of the body covers same distance in same time, or the frame fixed to a body and observer moves parallel. Bodies that have only translational motion behaves like particle. Suppose a frame, this is frame S, which is fixed on Earth, and an object moving with respect to observer attached to frame S dash. This is an object and this frame is S dash. Here the frame is X dash, Y dash and Z dash. This object is a car, this is a moving car. Here we fix a coordinate system which is named as X dash, Y dash and Z dash. Now if this car starts moving from here at any instant, suppose it is here, it moves like this, it reaches this observer, and after some time t dash it is here, and after that it is here, and finally it moves in a curved path and reaches final position. It reaches this position. If irrespective of time, either we see at t dash or t double dash, if the coordinate system attached to this car and this observer remains parallel, if this x-axis attached to this observer, this x dash axis attached to this car, at any instant, if these three are parallel, if this y-axis fixed to this observer and fixed to this moving car is parallel irrespective of time, this z-axis this z axis and this z axis is also parallel irrespective of time, then we say this car is performing translational motion. And for this motion we can treat this car as a particle if it travel sufficient large distance. Now the translational motion is of two types. One is called rectilinear motion, which is also called one-dimensional motion, simply called 1D motion. The second is curvilinear motion or two-dimensional motion. It is also called three-dimensional, maybe three-dimensional also. Now suppose a car, this car is at here. If this car is moving like this, then there are 3 points. If we choose 3 points, this point is A, this point is B, this point is C, fixed to this car. If these 3 points, suppose this particle A, this point A on the car, move in a single straight line, this B move in a single straight line, this C also move in a single straight line, so we can say this car is performing rectilinear motion, or this motion is also called one-dimensional motion. But if the same car is moving such that, suppose it is here and it is moving like this, not in a straight path, it is moving in a curved path. If the same 3 particles, let this particle be A, this particle be B, this particle be C, if these 3 particles are moving such that at any instant, suppose at any time t, this particle B, this particle C, this is A, this is B, this is C. All these 3 particles are moving such that the velocity at any particular instant is same. If the velocity of these 3 particles at any instant is same, means their magnitude is same, their direction is same, so we can say this car is moving in a curvilinear motion, or this motion is also called two-dimensional or three-dimensional. This is also a type of translational motion. Now the meaning of one-dimensional motion. Now suppose this is a motion. Suppose this red line, this red arrow represents the motion of a particle. Suppose this is a particle which is moving from origin like this, in this direction. The same particle is also moving in this direction. If I say this motion and this motion, its magnitude is same, its direction is same. But if I change the coordinate system, this is called one-dimensional motion, this appears to be two-dimensional motion, and this appears to be a three-dimensional motion. But in this coordinate system it appears to be one-dimensional, in this coordinate system it appears to be two-dimensional, here it appears to be three-dimensional motion. But as we know, the motion is same. So if the motion is same, the minimum dimensional possible in any coordinate system is called the dimensional of motion. Minimum dimension is called dimension of motion. So minimum is one dimensional motion. So this motion is actually one dimensional, whether we watch it in this frame or in this frame or in this frame, it is always one dimensional motion. So this motion is one-dimensional motion. In this frame it appears to be three-dimensional, but still it is treated as one-dimensional motion. So straight line motion is always called one-dimensional motion. Now if you watch a projectile, suppose this is our x-axis, y-axis and z-axis. Suppose I throw a particle like this. In this coordinate system, this particle moves in this position like this. It appears to be two-dimensional. But if the same particle is projected such that it falls like this, it falls here, it appears to be three-dimensional, though the motion is in a single plane. So if I say the first case is two-dimension and this is three-dimension, this is called 2D motion and this is 3D. The minimum possible dimension, because these two are same projectile, the minimum dimension possible in those two systems is called the dimension of motion. So either this motion or this motion is always two-dimensional motion. Now before moving to kinematics, we have to define some basic terms, such as first one is reference frame. Now reference frame, suppose this is our x-axis, y-axis, z-axis. We fix a coordinate. This is an observer. Suppose an observer is sitting here and he is doing all the calculation. Then this frame fixed to an observer from where he is measuring all the things, from where he is calculating the speed, velocity, acceleration, distance, displacement. This is called frame. Now the second one is distance. Now suppose a particle is at this position A. It moves like this to this position B. This is the initial position of the particle. This is the initial position of the particle. This is the final position of the particle. This is the final position of the particle. The particle is moving like this. If I say what is the length of path traveled by the particle, then if I measure the length of this path, then this length of this path is called distance. This length can very easily be measured by putting thread on this path and measuring the length of this thread. The length of this thread will give you the actual distance traveled by the particle. So distance is actual length travel. The unit, this distance is actually a scalar quantity. Its unit is either meter, kilometer, nanometer, micrometer, you can say, light year, Fermi, and so on. The other definition is displacement and position vector. Now first I will define this position vector. Now suppose this particle is moving. Initially it is at here. Finally it is at this position. If I draw a vector starting from this position, this vector. If I draw a vector like this vector is called position vector. This is called position vector. Since this is the initial position of the particle, so it is called initial position vector of the particle. The velocity at initial instant is also called, the velocity at this point is called initial velocity. The speed at this point is called initial speed. The position of the particle at this instant is called initial position vector. So position vector is a vector which starts from origin and it ends at the final position of the particle. Now since this position vector ends at the initial position, so it is called initial position vector. This vector which ends at the final position, this is called final position vector, RF. Now a vector which starts from A, the initial position, and end at the final position, this vector is called displacement. The displacement vector is a vector which starts from initial position and end at the final position. This is called displacement. Now I can say, from triangle law of addition of vector, I can say Ri plus displacement is equal to Rf. So from here we can say displacement is equal to Rf minus Ri, and this is read as change in position vector. So displacement is actually the change in position vector. Sometimes student got confused and say displacement is shortest distance. Actually shortest distance is not displacement, it is actually the magnitude of displacement. Because displacement is a vector quantity, it is having magnitude as well as direction, whereas shortest distance is a scalar quantity, it is only having magnitude. So we can never say shortest distance is equal to displacement, but we can say the magnitude of displacement is shortest distance. Average speed. Average speed is defined as the total distance traveled. It is total distance traveled by total time taken. The unit is meter per second. It is the total distance traveled divided by total time taken. It is irrespective of time when the particle is moving fast or moving slow. It is total distance divided by total time. The unit is meter per second. It may be kilometer per hour. The other is instantaneous speed. Instantaneous speed is simply defined as ds by dt. This is read as rate of change of distance. Instantaneous speed is the speed at an instant. It is simply equal to the rate of change of distance. Its unit is also meter per second or kilometer per hour. The next definition is average velocity. Average velocity is defined as V average, which is equal to total displacement divided by total time. Average velocity is total displacement divided by total time. Its unit is also meter per second or kilometer per hour. We can say the magnitude of average velocity can never be equal to average speed. Sometimes people usually say that magnitude of average velocity is equal to average speed. This is not true. This is true only when the particle is moving in a unidirectional motion. In unidirectional motion, the magnitude of average velocity is equal to average speed. But otherwise, average velocity can never be equal to average speed because velocity is a vector quantity and this average speed is a scalar quantity. The next is instantaneous velocity, simply represented by V. Instantaneous velocity is read as a rate of change of displacement. Here S represents the displacement. It is also equal to the rate of change of instantaneous position vector. Instantaneous position vector, we can see from here, we can see the instantaneous position vector as, suppose this is the vector, this particle is moving like this. The instantaneous position vector means a vector which start from origin and end at the initial instantaneous position of the particle. This vector is called instantaneous position vector. This at an instant, it is here. So this is called the instantaneous position vector. So the instantaneous velocity is read as rate of change of displacement, or that is also equal to rate of change of instantaneous position vector. Its unit is also meter per second or kilometer per hour. The magnitude of instantaneous velocity, we can say instantaneous velocity is equal to instantaneous speed. This statement is always wrong, but we can say instantaneous velocity, the magnitude of instantaneous velocity equal to instantaneous speed. This is always true. This statement is always true. The magnitude of instantaneous velocity is always equal to instantaneous speed. Next one is average acceleration. Average acceleration is defined as the total change in velocity, means final velocity minus initial velocity divided by time. Average velocity is the total change in velocity divided by total time. Its unit is meter per second square or kilometer per hour square. The instantaneous acceleration. The instantaneous acceleration is simply represented by A, and that is equal to dv by dt, which is also read as the rate of change of instantaneous velocity. Its unit is meter per second square or kilometer per hour square. Now before moving to kinematics in one dimension, we will discuss some terms. The first term is when displacement is equal to distance. Now usually people say distance is equal to displacement in case of one dimensional motion. But this displacement can never be equal to distance. Because displacement is a vector quantity, this is a scalar quantity. It is actually vector, and this is a scalar. So a vector quantity and a scalar quantity can never be equal. Distance, displacement, the magnitude of displacement may be equal to distance only when the particle is moving in a straight line and the direction of motion is not going to change. That is called unidirectional motion. This is valid in unidirectional motion. Otherwise, the magnitude of displacement is always less or equal to distance. When displacement is equal to instantaneous position vector, as we know, the displacement Rf minus Ri is called displacement. Rf minus Ri means the final position vector minus initial position vector is called displacement. If Ri is equal to 0, if initial position vector of the particle is 0, means it starts from origin. If the motion starts from origin, then the displacement is equal to position vector at that instant. Then R is equal to displacement. Otherwise, the position vector and displacement means two different things. V is equal to dr by dt, that is also equal to ds by dt, because we know S, that is displacement, which is equal to R minus Ri. Now we know Ri is the initial position vector, which is always constant. So ds by dt is always equal to dr by dt, because dri by dt that is always equal to 0. Instantaneous speed. This is always true. Magnitude of instantaneous velocity is always equal to instantaneous speed. This statement is 100% valid. It is unconditionally true. What is dr by dt? Dr by dt is actually the rate of change of position vector. This is read as instantaneous speed. This is actually instantaneous speed, but dr by dt is the rate of change of magnitude of position vector. These two may be same under one condition, that the body is performing unidirectional motion. Otherwise these two can never be equal. Here we will discuss one question about for discussing all this definition. The question is a particle is moving in xy plane in a semicircular path of radius r with constant speed v0. It travel start from t is equal to 0 at a and finally slowly it reaches this point b in time that is equal to pi r by v0. Now you have to calculate the actual distance traveled by the particle. So the distance traveled by the particle is the length of path. So as we know, the length of this path is pi r is half the circumference of the circle. So this is the distance traveled by the particle. The second question is displacement. As we know, displacement is defined as the change in position vector, that is rf minus ri. The displacement, you can say the displacement is, if I say the initial position vector, this vector which start from origin and end at b, this is called the final position vector of the particle, this is rf. Whereas this vector which start from o and end at a is called initial position vector, that is ri. And we know the change in position vector, that is rf minus ri. Here rf is the magnitude of this rf is r and the direction is minus ri cap. So it is minus ri cap. This is the position vector, this is the final position vector, minus the initial position vector of the particle is capital R I cap. So it is r I cap. So the total displacement comes out to be minus 2 r I cap. This is the total displacement of the particle. Now as we know, some people used to say the displacement. If I say what is the displacement, so usually students say displacement is equal to 2r. So we know displacement can never be equal to 2r because 2r is the magnitude of displacement. It is a scalar quantity. Displacement is a vector quantity. It must have magnitude as well as direction. So the displacement of the particle in this time t0, that is pi r by v0, is minus 2r I cap. The next question is average speed. As we know, average speed is defined as the total distance traveled. As we know, the total distance is pi r and the time is, that is equal to pi r by v0. So I will substitute it here. It is pi r by v0. So from here we get the average speed as v0 meter per second. Average speed is the total distance traveled divided by total time taken. The next heading is average velocity. As we know, average velocity is defined as v average, which is equal to the total displacement. It is displacement divided by time. So the displacement of the particle is minus 2r I cap, as we have already discussed, and the time is pi r by v0. So it is pi r by v0. Solving it, average velocity is the displacement minus 2r I cap by pi r by v0, which is equal to minus 2 v0 by pi I cap, because this r will cancel out. This is also in meter per second. This is the average velocity of the particle. The next one is the average acceleration. As we know, the average acceleration is defined as the total change in velocity, means final velocity divided by minus initial velocity divided by total time t. Now we can say is usually the answer comes out to be 0. Usually people say the average acceleration means 0 because the speed of the particle is not changing. Here we will discuss if the speed of the particle is not changing, then also the average acceleration is not 0 because the direction of the velocity is continuously changing. So when the particle is at b, it is moving downward. So the final velocity at b, this is the final velocity of the particle. When it is at a, it is moving upward. So we can say it is v initial. So final velocity is minus v naught j cap minus initial velocity is v naught plus j cap. This is plus j divided by total time is pi r by v naught, which comes out to be minus 2 v naught square by pi r j cap. So this is the average acceleration of the particle. The next is average speed. This is in meter per second square. Instantaneous speed. Now instantaneous speed is the speed at an instant. So we can say at an instant the speed of the particle is always constant. So instantaneous speed is always constant, which is equal to v naught. Speed is constant, so its instantaneous value is always fixed. The next heading is instantaneous position vector. Now we can say when the particle is moving, for instantaneous position vector, this is the vector. Suppose the particle is at P. Now this vector which start from origin and end at the position, this vector is called instantaneous position vector R. For instantaneous position vector, we can say the particle is initially here, it is at any time t, it is here. This is the instantaneous position of the particle. This vector is the instantaneous position vector. If I say this angle is theta, then we can say theta is equal to s by r, and we can say s is the distance traveled by the particle in time t. So this is your s, which is equal to v naught into t, because the particle is moving with a constant speed. So theta comes out to be v naught into t by r. This is the angle subtended by the particle, the position vector at any time t with positive x-axis. So I can say the instantaneous position vector is xi cap plus y j cap, where x and y are the x and y coordinate of this position vector at any time t. So this is your x and this is your y. So I can, from right angle triangle, we can say x is equal to r cos theta. It is r cos theta I cap plus r sin theta j cap, where theta is v naught t by r. So this is the instantaneous position vector of the particle. This is the position vector at any time t. The other is instantaneous velocity. The instantaneous velocity is simply defined as v, which is equal to ds by dt, the rate of change of displacement, or that is also equal to dr by dt, the rate of change of instantaneous position vector. So this is equal to, this is dx by dt I cap plus dy by dt j cap. So this is the instantaneous velocity of the particle. So it comes out to be, if I differentiate r with time, then we get that is equal to minus v naught sin theta I cap plus v naught cos theta j cap. This is the instantaneous velocity of the particle, velocity at any time t. The next heading is instantaneous acceleration. So instantaneous acceleration is again defined as the rate of change of instantaneous velocity. It is dv by dt. Now if I differentiate this velocity, means this term again, then I can say it comes out to be minus v naught square by r cos theta I cap minus v naught square by r sin theta j cap. So this is the instantaneous acceleration of the particle. So I can write this again as minus v naught square by r into cos theta I cap plus sin theta j cap. From here it can be written as, from here I can say r vector r divided by vector r, that is equal to cos theta I cap, it is cos theta I cap plus sin theta j cap. So in place of cos theta I cap plus sin theta j cap, I can write this as vector r divided by mod of r, or this is r cap. Since the acceleration or this acceleration is always directed towards the center, it is opposite to the position vector of the particle. So we can sometimes say this is also called centripetal acceleration. Centripetal acceleration means it is pointing towards the center of the circle. A particle is moving along x-axis following equation x is equal to t square minus t plus 1, where x is in meter and t is in second. Starting from t is equal to 0 to t is equal to 2 seconds, we have to calculate the distance traveled by the particle and the displacement of the particle. So as we know, the distance is the actual length traveled by the particle. So first we will calculate the displacement. So x coordinate of the particle is given by t square minus t plus 1. So I can say the instantaneous position of the particle is x I cap, since the particle is moving only along x axis. So x can be written as t square minus t plus 1 I cap. This is the x coordinate of the particle at any time t. Now at t is equal to 0, at t is equal to 0, we can say the position vector of the particle is called initial position vector, and the initial position of the vector of the particle is 1 I cap. At t is equal to at t is equal to 2 seconds, we can say the position vector is called final position vector, and at t is equal to 2 seconds, the position vector of the particle is given by 2 square minus 2 plus 1 I cap, which is equal to 3 I cap. So the displacement of the particle is final. So we can say displacement of the particle is equal to Rf minus Ri. So it is equal to 3 I cap minus 1 I cap, which is equal to 2 I cap. This is the displacement of the particle in first 2 seconds. When we talk about the displacement of the particle is 2 I cap. When we talk about the distance is the actual length traveled by the particle. So we can say at t is equal to 0, as we have already discussed, at t is equal to 0, the particle is at t is equal to 0, the particle is at 1 I cap. So this is the position vector of the particle, it is at 1 I cap. So this is the initial position vector of the particle, this is Ri. At t is equal to 2 seconds, t is equal to 2 seconds, we can say the particle is at 3 I cap. So this is the final position vector of the particle, this is equal to 3 I cap. So the displacement is 3 I cap minus 1 I cap, that is equal to 2 I cap. But when we talk about the distance means the actual length traveled by the particle. So when the particle is at A, suppose at t is equal to 0, it is at A, and at this instant it is at B. When the particle is at A, its velocity, we have to calculate velocity. So V comes out to be dr by dt, which is equal to 2t minus 1 I cap. So the velocity is given by 2t minus 1 I cap. Now at t is equal to 0, the velocity of the particle is minus 1 I cap. So the particle is moving backward with a velocity of minus 1 meter per second. When it comes to rest, so when v is equal to 0, we can say at that instant t is equal to 1 by 2 seconds. So when the particle comes to rest, it is supposed at this point, at this particular particle is at rest. So we can say at this instant the position of the particle, if I substitute t is equal to 1 by 2 here, I will get the position as r is equal to 1 by 2 means 1 by 2 square, 1 by 4 minus 1 by 2 plus 1 I cap, which is equal to, it is 1 by 4 minus 1 by 2 plus 1. So it is 1 by 2 minus it is 3 by 4. 3 by 4 I cap. So the position vector of the particle is this position vector. This is equal to 3 by 4 I cap at t is equal to 1 by 2 second. At t is equal to 1 by 2 second, the particle is at 3 by 4 I cap. So the distance traveled by the particle is this distance. We can say this distance. This is the distance traveled by the particle. This distance can simply calculated by this distance is 1 meter. This is 3 by 4 meter. So it is 1 by 4 meter. So first it goes backward, then again forward, and finally it reaches this point B. So the total distance traveled by the particle is 1 by 4 plus 1 by 4 plus it is 2. This distance is 2, this is 1 by 4, this is 1 by 4. So it comes out to be 2.5 meter. So the actual distance traveled by the particle is 2.5 meter. Next we have to calculate the average speed. So I can say average speed is total distance travel. Now we know total distance is total distance divided by total time. So total distance traveled by the particle is 2.5 meter and the time is 2 seconds. So it is equal to 1.25 meter per second. The next is we have to calculate. So average speed is 1.25 meter per second. Next is average velocity. So we can say average velocity is total displacement. Now we know total displacement is 2 I cap and divided by total time is 2. So it is 1 I cap meter per second. So average velocity is 1 I cap meter per second. Second is instantaneous speed. Now we know instantaneous speed. It is the magnitude of instantaneous velocity. Now we know instantaneous velocity V is equal to 2t minus 1 I cap. So instantaneous speed is 2t minus 1 mod of this, because speed can never be negative. So instantaneous speed is 2t minus 1 meter per second. The next question was instantaneous velocity. Now we know instantaneous velocity is 2t minus 1 I cap, which we have already calculated. The next is instantaneous acceleration. So we can say instantaneous acceleration is dv by dt, the rate of change of instantaneous velocity. So dv by dt, from here I can say dv by dt is 2 I cap meter per second square. This is the instantaneous acceleration. The next question is a point object moves such that its distance is x coordinate as a function of time is given by x square, that is equal to t square plus 1. You have to calculate the acceleration of the particle as a function of x. So we can say it is given x square is equal to t square plus 1. This is the x coordinate of the particle as a function of time. So if I differentiate both sides, then we get 2x dx by dt is equal to 2t dt by dt plus d by dt of 1, or this is equal to x dx by dt, that is equal to t, because dt by dt is 1 and d of 1 by dt is 0. So from here we get dx by dt, that is equal to t, or dx by dt is also v. This is equal to dx by dt, that is equal to t by x. So this is the speed of the particle as a function of time. Now we have to calculate acceleration. Now as we know, the acceleration of the particle A, that is equal to dv by dt. So we can say A is equal to d by dt of t by x. Now this is of the form u by v. So I can say A is equal to v means x, du by dx means dt by dt, minus u means t into dx by dt, divided by v square means x square. So A is equal to x minus t, dx by dt is v divided by x square. So this is equal to x minus t, and we know v is equal to t by x, so I will substitute it here, it becomes t x divided by x square. So from here we can say A is equal to x square minus t square by x cube. Now we also know x square minus t square, from starting we can say x square minus t square is 1, so it is 1 by x cube. This is the acceleration of the particle as a function of x. This is also a very fundamental question. It is 260 km from Indore to Bhopal. This is Indore. This is a city in India, in Madhya Pradesh. It is Indore, and this is Bhopal. This distance, the separation between Indore and Bhopal, it is given that it is 260 km from Indore to Bhopal by air. It is 260 km. When aeroplane move from Indore to Bhopal, it travel 260 km. It is 260 km from Indore to Bhopal by air and 320 km by road. Suppose this is road. By road, if the car is moving, the road moves like this. It is 320 km. From Indore to Bhopal, aeroplane travel 260 km and a bus travel 320 km. Now aeroplane take 30 minutes, so time for aeroplane is 1 by 2 hour. Whereas for time for bus is 8 hour. It is given. Find the average speed of the plane. So average speed of plane is, total distance traveled by plane is 260, whereas total time taken by plane is half an hour, so it is 1 by 2, which comes out to be 520 km per hour. This is the first question. Second is average speed of the bus. So for bus, average speed is, total distance traveled by bus, it is 320 km divided by time is 8, so it is equal to 40 km per hour. This is the average speed of the bus. The average velocity of the plane, C is average velocity of the plane. It is the displacement of the plane. As we know, plane is moving straight, so the displacement of the plane is 260 km, and the time is half hour. So it is again 520 kilometer from Indore to Bhopal. Now the D option D is find the average velocity of the bus. So we can say average velocity of the bus is total displacement of the bus. Now the displacement, the distance of the bus is 320 kilometer, but displacement of bus is only 260 kilometer. The displacement for bus and for aeroplane will remain same. So it is 260 kilometer from Indore to Bhopal. This is from Indore to Bhopal, divided by the time taken by the bus is 8 hour. So it comes out to be 32.5 kilometer per hour. Next question is, the position of the particle is given by r is equal to a cos omega t I cap plus a sin omega t j cap plus b t k cap, where omega is 2 pi by t and t is the time period of one revolution of the particle following a helical path. Find the distance moved by the particle in one complete turn of the helix. So we know the position vector of the particle is given by r, which is equal to a cos omega t I cap plus b sin omega t j cap plus b into t k cap. This is actually a. This is a. This is the position vector of the particle. Now we know the velocity of the particle. So velocity of the particle can be written as dr by dt. So dr by dt comes out to be, dr by dt is minus a, it is a omega sin omega t I cap, because we know differentiation of cos omega t is minus a omega sin omega t I cap, plus a omega sin differentiation is cos omega t j cap. The third term is bt k cap comes out to be b k cap. So this is the velocity of the particle. Now if I take the magnitude of velocity, it will give me, this is speed. So speed of the particle is a root over a square omega square plus a square omega square cos square theta plus b square. This is the speed of the particle, because we know sin square omega t plus cos square omega t must be 1, or in general we can say it is equal to root over a square omega square sin square omega t plus a square omega square cos square omega t plus b square. This is the speed of the particle. Now we can say the sin square omega t plus cos square omega t, when we take a omega square common, then it become cos square plus sin square is 1. So this is the speed of the particle, and if you see, speed is, so the speed of the particle is constant. So the distance traveled by the particle is, speed of the particle is constant. So we can say distance is speed into time, which is equal to, time means it is 2 pi by omega, so it is 2 pi by omega multiplied by speed means a square omega square plus b square. This is the answer.